Remember, there's three kinds of stuff. Two kinds of regular stuff and acids. So three kinds of stuff total. There's molecular or covalent stuff. There's ionic stuff. If you remember the molecular stuff, when we named it, we used prefixes. When we write the formula for it, we're also going to use the prefixes to help us. These are the steps, and you can see that I've already written out dinitrogen pentoxide. And I'll give you a couple more and show you how that works. So let's give you an example that you can work. Let's go tetraphosphorus diiodide. So with that, how would you go ahead and write that formula? Let's look back at the steps. Write the first element and use a prefix for a subscript, tetraphosphorus. P is phosphorus, 4. Write the second element and use a prefix for a subscript. I is iodide, 2. P4I2. That's all you do. Listen to what it is, write it down. For ionic stuff, we got two kinds of ionic stuff. We've got binary ionic stuff, which is 2 elements, remember binary. And then we've got ternary ionic stuff, which is when you've got 3 or more elements. All we're going to do is write the ions, crisscross charges, and simplify if possible. 3 steps. Write the ions, crisscross the charges, and simplify if possible. Realize here you're simplifying, but for molecular stuff, you're not simplifying. When you write the formula, notice it doesn't say to simplify. Here in ionic stuff, we are simplifying. So there's only those 2 instances you need to think about. Just don't get that confused. So let's do an ionic example. Magnesium bromide. For this, you're going to have to look at your periodic table to know what the charge of magnesium and bromine are. Go look at your periodic table real quick. So on the periodic table, we went ahead and labeled these. These were all +1 over here. These were all +2. Remember over here, we labeled these -1, -2, so on. If you find magnesium right here, that's a +2. And if you look over here, bromide, that's a -1. So write the ion, magnesium +2, bromide -1. It says to write the ions, crisscross the charges, so that 2 comes down here. Now just the number, not the charge. And then you bring down the 1 here. So we get Mg1 Br2. The easier way to write that is MgBr2. That's the final thing that you're looking for, MgBr2. That's how you write the formula for magnesium bromide. So let me give you one more. We'll go through the steps and then I'll explain why we're doing what we're doing, why we're crisscrossing, because that's important to understand why we're doing what we're doing. Let me give you one more, and we're going to do a little bit of a harder one. This is going to be called aluminum sulfate. Sulfate is one of your polyatomic ions, so that's not binary. So let's look at what the differences are there between ternary and binary. It works exactly the same, except when you crisscross things, you're going to put parentheses around the polyatomic ion. So you're still going to write the ions, you're still going to crisscross charges, you're just going to use parentheses and then simplify. Let's go back. Aluminum sulfate. So look on your periodic table. Aluminum over here. That aluminum's a +3. Sulfate, look at your list of polyatomic ions. Sulfate is SO4 with a -2 charge. So if we go back and look, aluminum sulfate is Al. That's got a +3 charge. Sulfate is SO4 with a -2 charge. What we're supposed to do is crisscross the charges. 3 comes down, lives here. The 2 comes down, lives there. So that'll be Al2 SO4 3. Notice I've made a mistake here. This is not SO43. This is SO43. So when I say you're supposed to use parentheses, it means use parentheses to show how many sulfates it takes. So you've got 2 aluminum ions for every 3 sulfate ions. You could not do this. Okay, I'll put the wrong one in pink. You could not do this, Al2SO3. You can't just replace the 4 with the 3. This is wrong because that's not how you write sulfate. You don't write sulfate SO3. You also don't do math with it. You don't go Al2SO12. You don't multiply the 4 and the 3 together. That would also be wrong. So let me tell you why we're actually crisscrossing. The reason why you're crisscrossing is you have to balance the charges. Here's an aluminum ion, has a +3 charge. Here's a sulfate ion. It has a -2 charge. The +3 and the -2 means that aluminum is given up 3 electrons and sulfate is picked up or gained 2 electrons. Well, the problem is that's not balanced. You have to have an equal number of electrons lost and gained. Or, in other words, the charges have to cancel out. +3 and -2 don't cancel out. So, what do I need? I need another sulfate. Now there's 1 aluminum for every 2 sulfate ions. Now it's a +3, and this is a -4. It doesn't balance out. Now the minuses are bigger than the pluses. So, I'll add another aluminum ion. Now the aluminum has a +6. Sulfate only has a -4 total. So I need 1 more sulfate. Now it's balanced. 2 aluminum ions and 3 sulfate ions combined together to make this compound called aluminum sulfate. It's Al2SO4 parentheses 3. Okay? That's why you're crisscrossing it. So you don't have to think about all of this. How many of each ion do I need? If you'll crisscross it and simplify, it'll work every single time. Okay, let me give you one where you're simplifying, and then we ought to be done, and you guys can go on with your happy little lives. So let's go copper 2 sulfide. So that's Cu with a +2. Remember, the Roman numeral tells you the charge. It doesn't tell you how many, tells you the charge. That's why we used it before. Here it's telling us the charge. Not how many, the charge. Copper's a +2. Sulfur, if you look at your periodic table, is a -2. Crisscross the charges, you get Cu2, S2, and then can you simplify a 2 to 2 ratio? Cu2, S2, that simplifies to Cu1, S1. So we simplify the ionic stuff when we can. So you guys get this in your notes, get these couple of examples, and we'll see you in class.